Hello auditors, my name is Yisheng. Today we are going to solve Ethernaut Vault Challenge using Brownie Python. I'm going to explain the vulnerability within this particular contract as well as how it affects real world situation. Let's begin. Okay, we are at Ethernaut Vault Challenge. You can see that in order to solve this challenge, we must unlock the vault. So this is the smart contract. Over here we have contract vault with a boolean which is true or false or whether it is locked or not. And then we have 32 bytes of state variable password. And then over here we have the constructor. So when we deploy or Ethernaut deploy this contract, they input a certain password so that password equals to the parameter that was given. Then over here we have a function unlock which takes in the password. So I believe that we should guess the password. So if the password is correct, the vault will be unlocked. So firstly, we have to understand the data structure and algorithm of smart contract. So over here, there is this very good article of understanding smart contract storage. So over here we have uint256, which is basically 2 power 256 minus 1. So this is 32 bytes. You can see that these 32 bytes will be stored at slot 0. And over here we have an array which has a determined size of 2. So basically there will be 2 slots, one for each element of the array. And then we have a structure entry over here. So you can see that there is 2 types of state variable as well. Then these particular variables are ID and value, which will also consume 2 slots. Moving on, this is additional info. We have a dynamically sized array, which is over here. So this is an array of structure. You can see that slide D basically is at slot 5, and the only thing that is stored there is the size of D. You can see that this is the particular hash. So if we put in D0, we will get D0 over here, so on and so forth. Then moving on to hash map or dictionary for Python. Over here we have 2 dictionary or hash map for E and F. You can see that this E is slot 0 is actually storing the location on the slot. So to find the location of a specific value within a mapping, you need the key and the mapping slots which are hashed together. So you can just put in, for example, E123, then they will actually refer to slot 6 to get the value out. However, in Ethernaut, you can see that we have a boolean here. So boolean is actually 1 byte. I'm going to explain how does Solidity actually optimize their slots. So for example, we have this contract here, and we have a bool, for example, bool A, and this bool A is actually 1 byte. So for example, you just at slot 0, S0, you just take 1 byte here. Now, if assuming that we have another boolean, so this boolean will also take 1 byte, and what Solidity actually does is that at slot 0, since there are some remaining space, they will just put 1 more byte here. So basically, for slot 0, you actually store 2 state variable of A and B. Now, since we understood how slot works, we will actually carry on to the exploitation of the contract. So we can begin by creating a directory at desktop. You can just make directory vault, but since I've actually created it, we can just cd, and then we can run Brownie init, which initializes the directory, and of course I've actually just run it. So let's just open Visual Studio Code. Okay, so Visual Studio Code has been started, and you can see that we are a brownie-config YAML file. So what this file is that before you run your scripts, your Brownie Python scripts, Brownie will actually check brownie-config YAML file configuration first. So over here we have our dependencies, and over here we have .env to our .env, which basically tells Brownie to get our environment variable via the environment file. And then we have our wallets to from key to our private key environment variable, which is at our environment file. So over here you can see that this is our private key, and then we have this particular API key. So what this is that since we are using the Gorally testnet, and Infura is a node provider for Gorally testnet, hence we must use this API key to interact with our smart contract within Brownie framework. So over here we have the contract vault, which is copied from Ethernaut. I've also actually created an interface to interact with this particular contract. The reason behind this is that if the contract is extremely long with just one certain functions, this will actually makes your life easier, and you can just call this particular interface. Moving on to our Brownie Python script, you can see that this is our contract instance and this is my address. And in order to get and solve this challenge, you must get the slot 0 and slot 1. So slot 0 is to check whether this contract vault, whether is it locked or not, false or true. And then we have this particular slot 1, which is basically our password that we can retrieve from slot 1. So to solve this contract, we just get the password from slot 1 and then pass it to our function unlocked through this interface. So let's just run the script. I'm going to pause the video and wait for the transaction to be mined. Okay, the transaction has been mined, and you can see that the initialized instance was locked at first and now it's actually unlocked. So the password for this particular vault was a byte of a very strong secret password with a smiley face, and then we just passed it into our interface and wait for the transaction to be mined so that we can get the latest instance of the variable, whether is it locked or not. So the vulnerability within this particular contract is that you will actually notice that the the contract is not private at all. You can actually just retrieve the password from slot 1. So all storage is actually publicly visible on the blockchain, even your private variable. And also, if you want to store your private variable, it's actually recommended to hash this password first, so that attacker will actually not able to see your password. If you liked my tutorial on Ethernaut Vault Challenge, please hit the like button and hit the subscribe button. Thank you for watching and have a nice day.